Hi, in this video we will learn about new indeterminate forms which appear as indeterminate powers. There are three kinds, and then I will tell you how to resolve these indeterminate cases. Okay, so we have two functions, and this time we are interested in limit of f of x to the power gx as x approaches to some number. Well, three different cases happens that each one will give us a new indeterminate form. When x goes to a, limit of both the base and the exponent are 0, then we have 0 to the power 0 indeterminate form. Well, you may say that, okay, I know that every number to the power 0 is 1. No, every non-zero number to the power 0 is 1. And we know that 0 to the power any non-zero number is 0. That's why you cannot decide exactly which one happens then, and that's one of the reasons that you see this as an indeterminate power. The other case is that we have infinity either in the base, so limit of this guy is infinity in the base, and limit of the power is 0. Then you have infinity to the power 0. Well, please note that if you have infinity to the power any non-zero, any positive number, it will be infinity. And if you have infinity to the power any negative number, it will be 0. But when you have infinity to the power 0, we have another indeterminate form. The last one is an interesting one. It involves still an infinity, but this time the base is 1 and the power is infinity as x approaches to a. In that case, we have 1 to the power infinity. So these three cases are the new indeterminate forms that we have to deal with. So how we can resolve these cases, how to deal with indeterminate powers. Well, the trick comes from this fact that if you have f of x to the power gx, you can write this as exponent of gx ln of x, f of x. This is in general true. If you have a to the power b, any two positive numbers, you can write them as e to the power b ln of a. Yes. So how does this going to help us? So then if you're looking for limit of x approaching to a, f of x, e to the power gx, you can find the limit of e to the power gx ln of f of x as x approaches to a. And then since e is continuous function, we can take the limit in, and we will have the limit of this guy here. Yes. So if you look at these cases, you're going either to have 0 times infinity or infinity times 0. So this is the first step. Use that trick, write it like that. The second step is that well, limit of gx ln of fx as x approaching to a is an indeterminate form of type product type, so 0 times infinity. Well, we know how to deal with that. We can turn it well, either 0 over 0 or infinity over infinity and use L'Hopital. So turn it to 0 over 0 or infinity over infinity and find it using L'Hopital's rule. And when you find that limit, in other words, you find this limit, let me call E, the original, note that limit of f of x to the power gx is not equal to that L. It is e to the power L. This is very important last step that we have to do, and let me just write it as the fourth step. So we do this trick, turn it into a indeterminate product, and then turn it into 0 over 0, use L'Hopital and solve it, and then put it in the power of L. Okay, we need to see these in the examples. So far, what is important is that these three cases are the indeterminate powers. Okay, let's go and find the limits. The example I have is here. Okay, paste. Find the limits. So we go one by one. Here, ln of 1 plus the limit of base is, well, ln of 1 is 0. And limit of the exponent as x approaches to 1 is 0. So what we have is 0 to the power 0 case. 0 to the power 0 is not the value of the limit. We have to work and find it. So how do we deal with these cases? So as we discussed about, limit of ln x minus 1 is same as e to the power limit as x goes 1 minus ln of ln of base times the power. And then we will study this guy separately, because now we have indeterminate product. So limit of x minus 1 ln of x as x approaches to 1. Oh, this is plus. I need to put plus, yes. And this is 0 times infinity, negative infinity, and indeed. Well, what shall we do? So turn it to either 0 over 0 or infinity over infinity. In this case, I will do ln of ln x 1 over x minus 1. And as you see, this is now infinity over infinity, and we can use L'Hopital's rule, which will give me the derivative of numerator is a ln x ln of ln x, the derivative of ln x, which is 1 over x over ln x, and this guy will give me negative 1x minus 1 squared. Okay, and x approaches to 1 plus. Very nice. Let's just simplify this thing. As I always say, algebraic simplification is always a good thing to do before you look for any other trick. Here we will get this guy as x approaches to 1 plus. Very nice. So here now we have 0 over ln x as x approaches to 1 is 0, and this is 1 times 0. So we have this time 0 over 0, and we can use L'Hopital's rule. And this will give me 2 times x minus 1. And this will be ln x plus x times 1 over x, which is 1, as x goes to 1 plus. Now, if you let x go to 1 plus, in the denominator, I'm going to have 0 plus 1, and it is non-zero. So that means that we have found the limit. So this is 0 over 1, which is 0. This is not the limit that we were looking for. This is just the limit of the power of e. And we found that it is 0. So e to the power 0 is 1. The limit we are looking for is 1, not 0. So that's how we find that one. Let's do another example. Okay, I will definitely need more space here. Okay, so let's see what situation we are in. When you look at this limit in this form, well, it is a little bit difficult to understand what is going on. But if you write it as this, because x root is the power 1 over x, yes, then you see that limit of x plus e to the power x as x approaches to plus infinity is plus infinity, and limit of 1 over x as x approaches to plus infinity is 0. Basically what we have is 0 to the power other way around, sorry, infinity to the power 0. Infinity to the power 0 is an indeterminate power, and we have to resolve it. How do we do that? Limit of x plus e to the power x to the power 1 over x is the same thing as e to the power 1 over, well, let me write limit of 1 over x ln of x plus e to the power x as x approaches to plus infinity. So this is the first trick that we do, and by doing that, now we have a limit of this form, which I can write it as x plus e to the power x over x as x goes to plus infinity. If you look at this guy, this is 0 times infinity indeterminate form. And if you do 1 over this, you will get this guy, which is now an indeterminate form of type infinity over infinity. And we can use L'Hopital's rule. And L'Hopital's rule in this case is what? 1 plus e to the power x, x plus e to the power x, and this is 1. This is limit of, simplify algebraically, as x approaches to infinity. Well, again, this is infinity over infinity. We can do another L'Hopital's rule. And what we will get here is e to the power x, 1 plus e to the power x as x approaches to infinity. Well, again, this is infinity over infinity, limit of x approaching to the infinity of another differentiation. So this will be e to the power x. And as you can see now, we can simplify and get just limit of 1 is 1. And here it is very important. What we found is not the original limit. This is just the power of e. Now we found that the limit at the power is 1, so we get this is e, and as a result, our limit, the original limit we were looking for, is e. Okay. The last example, find the limit of base as x approaches to plus infinity. This is 1 plus 0, which is 1, and limit of the power, this is infinity. What we have here is 1 to the power infinity. You have to know 1 to the power infinity, 0 to the power 0, infinity to the power 0. These are indeterminate powers. And we have to resolve them by doing the trick that we have been doing, using this long trick or E trick. So this will be e to the power limit of x goes to plus infinity of 5x ln of 1 plus 2 over x. And as you can see now, we have this limit, which is, interestingly enough, this is infinity times 0. And that's another indeterminate form, but we know how to deal with. Write one of them as 1 over 1 over itself. So in this case, I will write 5x as that. As x goes to plus infinity. This guy now is a 0 over 0. Yeah? And a 0 over 0, this is ln. Don't confuse it with limit. And 0 over 0 is something that we can use L'Hopital's rule for that. So this will turn into limit of the numerator is this guy over 1 plus 2 over x. And this is this guy. Well, I need simplification. There are a lot of things here going on. So let me just do that first before we start doing anything else. Okay, first thing you see, this is the numerator of the numerator, and this is the denominator of the denominator. So then this will give me negative 2 over x squared times, well, we could have simplified. Let me just write it as it is, 25x squared. And over there we have negative 5, 1 plus 2 over x as x approaches to plus infinity. And, well, you can cancel these two. And in the numerator, this will give us negative 50. And in the denominator, negative of 5, 1 plus 2 over x as x approaches to plus infinity. Well, you can see that the denominator is now just negative 5, negative 50. I could have simplified these numbers before, but we get the right answer. It doesn't matter at each stage. You did that. Well, it is important, again, to note that what you have found is not the value of the original limit. This is just the power of e, and we found this is e to the power 10 here, then that is the limit, e to the power 10. So in determinate powers, you need to do one trick and then turn the indeterminate form into indeterminate products, and then go from there, turn it into 0 over 0, use L'Hopital, solve it, and go back and find the original limit.